Calculus Unit 4, Day 35 Notes. This is Part 3. This time we are going to have the second derivative, and we're going to try to state all the conclusions that we can come up with about the graphs of the original function and the first derivative. So very similar to the previous ones. Um, Hopefully you've taken a shot at it, and we see that I came up with 4 conclusions for f of x and 7 for f prime of x. Originally I only came up with 6 for f prime of x, but we found another one. So let's take a look at it. First thing I can do is, hey, on the second derivative, I see that I have at 0 and 3, I have zeros. And I notice when it's pick any value, it's going to be negative. Different color here. It's going to be negative there, and then between 1 and 3, all the values are going to be positive, and then above 3, it's also going to be positive. So let's take a look at some of the conclusions about f of x. First one is that the original function has a point of inflection at x equals 0 because the second derivative goes from negative to positive. It changes signs. Okay, I know that the function is concave up on the interval from 0 to 3, union with 3 to infinity, because the second derivative is positive. Now notice here, at 3, it's 0, so I can't do 0 to infinity. So it's only where it's positive. And above 3 to positive infinity, it's going to be concave up as well. And the original function is concave down from negative infinity to 0, not including the 0. And lastly, since the second derivative is a cubic function, the original function is going to be a quintic function. So the original function is degree 5. Therefore, the second derivative will be degree 3. Okay? All right, let's look at conclusions about f prime of x. I'm going to write a bunch of these down, then we'll talk about them. Okay, so conclusions about the first derivative. In these, we're starting with the second derivative and we're learn the first derivative. This is similar to what we did on the first one or the second one when we had the first derivative and we were making conclusions about the original function. So it's going backwards one derivative. So the derivative is increasing from 0 to 3. Let me see if I get the picture in there. Because the second derivative is positive. And again, so from 0 to 3, it's positive, and then again from 3 to infinity, because the second derivative is going to be positive. I then know that the derivative is going to be decreasing from negative infinity to 0 because the second derivative is negative. Okay, so 0 to 3 and 3 to infinity is where the second derivative is positive, and from negative infinity to 0, it's negative. Therefore, the first derivative is going to be decreasing. Just like what we learned about when we had the first derivative is positive, the original function is increasing. First derivative is negative, the original function is decreasing. Okay, that's what 1 and 2 are there. All right, let's take a look at number 3. The derivative has a relative min at x equals 0 because the second derivative changes from negative to positive. Let's go look at that. So right here, it's negative below it, it's positive above it. Therefore, I can conclude that the first derivative has a relative min because the second derivative goes from negative to positive. Now, 4, 5, 6, and 7 are very similar to 1, 2, 3, and 4 over here. I'm going to try to match those up. Then number 4, the derivative has a point of inflection at x equals 1 and x equals 3 because the second derivative has a relative max or min. Now, we hadn't talked about that, but another way to look at it is, hey, that means the third derivative is going to change signs, and that's where 2 derivatives away it changes signs. 1 derivative more has a relative max or min, therefore the one before has a point of inflection. Okay, let's go to number 5. The derivative is concave up on the interval from negative 1 to 1 and negative infinity to 1, and then again from 3 to infinity because the second derivative is increasing, which again means the third derivative is positive. And up here we said, hey, the original function's concave up because the second derivative was positive. That's two derivatives away. Here, I also know that one derivative away it can be increasing, which is the same as two derivatives away being positive. Okay, 3 and 6, so the first derivative is concave down on the interval from 1 to 3. Why? Because the second derivative is decreasing. And they didn't ask us about the third derivative, but just trying to make that connection. I could do this forever and ever, between one derivative away, two derivatives away. So since the third derivative will be negative, it means the first derivative is concave down. Okay, then the last one, the first derivative is going to be a quartic function because I know the second derivative is a cubic function. Okay, so there's some calculator active questions that you're going to work on, and we will go over those together as a class. But other than that, that takes care of day 35 notes.